Now the next thing that we'll talk about in this video are applications of magnets. Now when we'll be talking about the applications, we will keep in mind that a categorization that we discussed previously of magnetic materials was between temporary and permanent magnets, right? Because the type of magnet that we have, it does affect its usage in the application. Now if I just quickly recall what permanent magnets really were, then permanent magnets are materials that are basically very difficult to magnetize and also to demagnetize. So once they do get magnetized, they retain their magnetism for extended periods of time. So similarly, we also want permanent magnets in applications where we want the magnet to always be switched on or for it to always display its magnetic properties. Just to recall, let me write this here, that permanent magnets are difficult to magnetize and demagnetize. Stuff that we've done previously as well. And the primary example that will be asked of you in your papers is steel as the example of permanent magnets. So let's have a look at some of the applications of permanent magnets. Now one of these applications is in credit or debit cards, where you basically have a lot of information stored on this magnetic strip. And for example, whenever you have to make a purchase using a card, what you basically do is you place the card near that card reader, and that card reader detects that changing magnetic field, and it basically then allows a purchase to happen, right? So this is also used in credit and debit cards. Another application of permanent magnets is of the microphone, where you have some incoming sound, and that incoming sound basically makes this coil of wire move around this magnet, and because of something called the generator effect, which we'll study later on, a EMF is induced which leads to current being produced. So microphones are also an example of the applications of permanent magnets. By the way, not all types of microphones work of this technology. The ones that do are called dynamic microphones, but there are different ones called ribbon and condenser microphones. Those have slightly different technology. But one type of microphone does utilize the magnet in such a configuration. The next application is something we will study in detail later anyway, but just for completeness, I'll also mention this here, is that of the loudspeaker. So the loudspeaker we will study in detail later as well, as I just said. With the loudspeaker, the idea is that you have some electrical signal, which is basically the current applied, and when the current is flowing inside a magnet to which this is attached, there's a force which causes the cone to move back and forth, and this is how sound is produced in the case of what we call a moving coil loudspeaker. Right now we'll just call this a normal loudspeaker, right? So these are these three applications: credit, debit cards, microphone, and loudspeakers. Now when we talk about electromagnets, the examples are more complex intellectually as well, and you need to know this. So let's talk about temporary magnets now. So temporary magnets, just as we talked about a permanent magnet, so a permanent magnet is difficult to magnetize and demagnetize, and for a temporary magnets, these are easy to magnetize and demagnetize. Again, stuff that we've studied before as well. But if you think about the applications of temporary magnets, then we want to use these in places where we want to have our magnetism, basically we can control when it's switched on or switched off. So easy to magnetize and demagnetize. And these will soon become apparent when we talk about the ideas and the applications which are to follow. With the temporary magnets, the example was soft iron, and now let's have a look at the applications of these. And you might have probably guessed that when we talk about temporary magnets, the way that we switch that magnet on or off is basically with the help of an electric current. So what is going to come up is basically electric circuits, and I hope all of you are familiar with electric symbols so that you guys can understand the applications that I'm about to talk about now. So the first example is of something called a reed relay, which is also sometimes just called a simple relay. So let me put this in brackets because it's basically called an electrical relay. You should also know its electrical symbol that looks something like this. So basically like a resistor, but instead with the wires coming out on top, and that's basically because this electrical relay uses some sort of magnetic ideas to close the switch of another circuit, right? So what a reed relay does, as we'll see, is that it can be used to control a high voltage circuit even though it itself is low voltage. So this is often asked in your paper as well, which is what are the advantages of using a relay? So first of all, you should know it's a switching device which can control a high voltage appliance or a high voltage circuit while itself being low voltage. So by doing so, we achieve some distance against the high voltage circuit, and this can prevent the risks of electrocution. Now, how do you understand this? Is basically it's better for you to be exposed to a 12-volt battery versus being exposed to 220 volts from the electrical main supply, right? So that's basically the advantage of using reed relays, because a lot of people, when they'll be exposed to this diagram of a reed relay and how it works, they'll say, why don't we just have a simple switch? So these are the advantages that a relay gives you over just normally manually switching the appliance on and off. So let's see how this works. Let's give ourselves some space to work with here. So this is the diagram of a relay taken from an actual past paper question. Now basically here the appliance of interest is the electric motor, and we turn it on. We want to turn it on, and instead of having a switch somewhere here in series so that I can just switch it on, because this is a pretty large battery as compared to just this single cell, I'll now be using a relay. Now sometimes it could also be that instead of just this being a pretty heavy battery, it could also be, for example, a 220 volts main supply, as I was just talking about, to switch on this electric motor, and instead we use the relay. Now how does the relay work? Let's just talk about this. Now instead of a switch on this side, I'll just be closing a switch on this side, and when this switch is closed, this circuit is going to be completed. There will be a closed loop, and current will start to flow from the positive terminal of the battery to the negative terminal. Now when the current is going to flow, this is going to cause a current in this solenoid, and as a result the iron core inside the coil, so because of the current in the coil, the iron core is also going to become magnetized. This iron armature is pivoted about this point, so when this becomes magnetized, it would also induce poles in the iron armature, attracting it towards itself. But because this is pivoted, as this end moves down, this end would move to the right, making the contacts touch and hence switching on the electric motor. Fair enough. Now let's write something down regarding this. Now the same things are also written here. So when the switch S in the primary circuit was closed, the current flowed through the coil, and flowing through the coil, it also magnetizes the electromagnet, which in turn attract the armature because of induced magnetism. As this end of the armature moved down, this end moved to the right. So the armature closed the contacts in the secondary circuit, the larger high voltage circuit, and this makes the motor turn because the electric circuit on the right is now complete. Sometimes the examiner will also ask this question, that why do we use an iron core and why do we not use a steel core? And the reason is very straightforward, because for the iron core, you know it's only going to be magnetized as long as you close the switch, and that turns on the electric motor. and when you turn it off, this would get demagnetized back again and the electric motor goes off. If you had a steel core, it would become permanently magnetized because of the current, and even with the switch open, it would still cause the motor to be on, right? So that's not really what we want here. Now, once you've understood the first application, the others become really easy because it's just the same principle which is used in all of those. The next application is related to something else, which is called a reed switch, and it's very similar. That was a reed relay. This is a reed switch.
And the idea of the reed switch is actually very similar to the idea of a relay. So this is basically what the reed switch is, and each of these parts, which are now slightly apart, these are basically what are called the iron reeds. So these are the iron reeds, and basically the idea is that because these are made of iron, we know that whenever a magnetic field is here, it's going to induce magnetism in both of these, and the magnetism will be such that that would make the reeds come together, and this could then be used to switch on some external circuit. Now in our case, this method of magnetization could very well be just a solenoid. So let's say if we have a solenoid around the reed which goes here like this, and whenever we switch on this circuit, that makes current flow into the solenoid, and there would be a magnetic field around the solenoid which also induces magnetism into the iron reeds, making them come together, and I can use this to control an external circuit as well. As I also stated previously, the relays is really what is part of the syllabus, but I'm doing these as well just so that if the examiner gives you a question regarding this, you already have some background knowledge to confidently tackle that question. Let's go on to the third one. So this one is the electric bell, and again it's the same idea. Often it's going to be this way, that you will be given a diagram, a circuit diagram of an appliance that you know or that you not know, and you'll basically have to explain using the diagram and using ideas of magnetism and electromagnetism as to how you think the circuit will work. So this is the diagram of the electric bell, how the bells in our schools work, the older types of bell which are available in our schools. That's where we see this being used. So first of all, you'll have this DC supply, a battery, and right now the circuit is not connected, it's not a closed loop. But when I push the bell, then these contacts come into touch, and then this completes the entire circuit. So current flows through here into the solenoid, this coil of wire which is wound around an electromagnet. So when the current flows, the electromagnet also gets magnetized, and it pulls this the iron armature towards itself, making the hammer hit the gong, and this produces the sound. Let's have a look at the fourth one. And again, it's also worth noting here that when this hammer hits the gong, then the contact is lost at this point, so this entire circuit then gets disconnected. So the bell then sounds for only a short time, and then this keeps on happening again and again for as long as you keep pushing the bell, and the hammer keeps hitting the gong and producing the sound. The last one is the trip switch, which your syllabus previously used to call a circuit breaker. So that also uses electromagnets in it. So this is how the circuit diagram of a trip switch or a circuit breaker looks like. So you have an electromagnet here. This is the pivot, and about this is placed a fixed bar, an iron bar which is in contact like this, and this spring is stretched right now. So what the spring wants to do is it just wants to go back to its original length. And how will this happen here is, we know that the trip switch is supposed to be thrown, or it's supposed to be opened when the current exceeds a certain value. So here the electromagnet is chosen in such a way, when a current exceeds that predetermined value, then the magnetism gets strong enough to actually pull this iron bar towards itself, and then the spring collapses, breaking the contacts here. So this circuit, that whatever it was part of from here, so if I just draw it, this is maybe like a circuit which contains a battery and a resistor, right? So when this current becomes large enough, this iron bar goes upwards because it would be attracted by the electromagnet because of induced magnetism. The spring collapses, so whatever this part of the circuit was, the contacts get broken as this part moves to the right. So the contacts get broken, and then there's now no longer a closed loop, so the current stops flowing. So these were a few applications of the electromagnets. Some people do it with electromagnetism. Now formally in the next video we'll be starting the principles of electromagnetism along with the rules and everything. So see you there.